Hi, I'm Kake, and
Hey, can we,
we're Team 3, and we're going to talk about Arduino controller design, which is an IC board. In today's lecture, we'll cover 4 basic topics. The first one is the board itself, Arduino, and the XP basics. XP is the wireless addition to Arduino File, which should make it wireless connectable. And the second topic will be the joystick interface, which is connected to the file to know how to control other stuff. And the third one, we're going to talk about how to use it to do motor control. And the fourth one, we're going to talk about the interrupts of the file. First, I'm going to talk about the background of the file. The file is based on a microprocessor, ATmega328, and it runs at 3.3 voltage at 8 megahertz. And for our program, it's actually much faster than what we need, so it's a very good speed. And to program the file, you need, well, they have the Arduino have their own codes, and they're all in this web page if you want to look at them. But most of them are C++, C-based, and so if you guys are familiar with that, you can easily get used to it, and it's very easy to use. And on the board itself, there are no headers on the file that comes with the package, but you can solder any of the pins, and the pins include, well, the main ones are the 14 digital I input-output pins, and out of the 14 of them, 6 of them could be turned into PWM output, and they're 8 bits output, so it's something that we're going to use for our motor control, and it's very useful. And how you get from the analog input into a digital output of PWM, we use this code analog write, and that's how we do it. And there are also 8 analog inputs, as I said before, because, well, these analog input are 10-bit resolution, and which that actually means that it takes the reference voltage and it times it by the values that it takes, and then divided by the 10-bit resolution, which is 1024, and then you get the actual value in hex. And it also has a 32K byte flash memory, and that's where we store our program. And out of the 32K bytes, 2 of them is actually used for the bootloader, so it's like the microprocessor. And on here, this is actually the top part of the file board. On this one is the USB connection, and this one is a battery connector. The file board could be powered by either using a USB supply, a power supply, or the battery supply. But the flexible thing about this is you can actually plug in a USB into the USB supply, and then hook up a lithium or whatever rechargeable battery into the battery supply, and it automatically actually recharges the battery. So then afterward, when you're done with the USB, you can just take it out and just have the battery operating it, so you don't even have to pull in the wall socket. And so that's the wired part, and I've already talked about their analog pins and digital pins. Those are data connection. And to use, well, File is actually built, well, Arduino it has a lot of boards, and File is actually built specifically for wireless connection. And on the File board, at the back of it, there's a XP socket that is the radio transfer or the receiver, and they run at a 2.4 gigahertz, right? To program the there are 2 ways to load a program into the File board. The first way is to just connect the computer and load the program directly into the board. The second way is to actually use an adapter as a programmer to send the program wirelessly into multiple or singular boards, whatever you like, into whichever file that has another XP receiver in on it. And first of all, well, I'm going to talk about how to do it wirelessly. And first of all, well, this is the back of the adapter that we're going to use. It's called the Explorer, XP Explorer. First of all, well, you just have to short these 2 nodes together, and then you're ready to go. Well, you have to connect it to the computer, and then you have to download this XCTU which is available from Arduino's website as well. It's very simple to use configuration thing. And after that, you choose the right port from your computer. For example, if you are using USB on COM3, then you just scroll down and click on it. And then you choose the baud rate. And for our file, the baud rate is 576,000. So that's what you have to choose. Otherwise, it's going to clash. Well, sometimes it actually works if you chose something a bit off, but it's better to completely match with it. So this is the basic parameters for the modem configuration to see how, well, you have the adapter, right, and the other board, the file board, where you want to run the program, well, load the program into it. So first of all, I talked about how it runs at a specific frequency, which is 2.4 gigahertz, but well, you don't want other devices or other XP boards to be interfering with it, so you would have to set a specific PAN ID that all of the program, well, all of the XP components you want to be on. And so, well, you have four digits you can choose, and you can just choose a specific one, but each of them, of course, have to be the same. And this value BD, you have to pick the right microprocessor, and for our case, it's just 18 mega 328. And it's actually, you don't have to remember any of this. On the XCTU program, you just have to scroll down. The value comes with the microprocessor, the name of the microprocessor, so you can just pick whichever that matches. So here are two more IDs. There are also the values that you can choose yourself. The my one, it's actually, say, from point A, XBA to XBB, well, they should have a different ID, so then you can tell which one is which. So my source is the one that you want to set an ID for. So for example, I set the source as 0000 and the other one as 00001. Then you know when I want to load program from the programming to the destination, then I'll go from 0000 to 0001. So that's the next one, DL, what is what it means. So you set DL to where the destination of the programming would go. And there's another way of doing it. If you set the DL as FFFF on the programming, the adapter itself, then it's going to send across every other XP that's set to allow programming. So you don't have to do it one by one. And another, well, these three, this is just you're just choosing which digital pin to connect the programming to. And DI, well, it's kind of like a reverse kind of logic with DI is digital input, but it's actually saying that you're inputting the program through the cord into the XP radio and then it's outputting. So that's actually the transmission. So it's actually out. And on the receiver side, where you will want the file to be programmed, you actually do I. That's digital output. And this is just it's just additional function where you can set the program to monitor where the IC, well, there's change of input on the IC. For example, for this one, well, I set 3 to be the programming digital pin to read and write. So I set this to monitor that, and we'll get values whenever it changes. And this RR is, well, it's wireless, so there are chances when it fails. So you can set a certain value to keep on trying until it quit trying to program the destination. And this serial interrupt is just, well, it's a radio frequency. If it has a PAN ID somehow, someone knows your PAN ID, then it's gonna receive some signal into the board. So, well, for example, for the programming parts of it, you don't want anything to be interfering with what it's trying to do, because it's usually just transmitting programs into other consoles. And by setting the value to the 16 Fs, then no matter what is being transmitted or received on the programming board, it will not interfere with what it's doing. And on the other hand, the destination, you want them to be able to modify, right? So the programming, the values you set is 0xFFFF. That way it can be programmed.
Hi, I'm Ali, and I'll talk about how does the analog joystick interface with the Arduino. And first of all, I'll talk about the type of joystick available in the market, which are the digital joystick and the analog joystick. First of all, the digital joystick, which based on switches, and they are either off or on, and they are either lighting 1 or 0. An example of this is the Atari joystick. And the second type of joystick is the analog joystick, and they are used for directional movement, and they are based on 2 potentiometers. And an example of them are the Xbox controller and Sony PlayStation controller. And for our design, we use the analog joystick because it's more suitable for our design. And they are we want a joystick that helps us control generating different type of pulse modulation signal. To explain how is the analog joystick interface with the Arduino, I use this diagram where we can connect the 3.3 volt to the VCC from the Arduino, and according to the position of the joystick, we change the resistance, the potentiometers, and according to that, we get new voltage value. The new voltage value is supplied back to the Arduino from the analog pin, and we can use this feedback from the joystick, the Arduino, to do any other applications. And this image is representation of the diagram I showed before, and it shows the connection between the Arduino and the joystick. And to do any application or take advantage of the feedback from the joystick, we have to divide the analog bit panning by 4 because the Arduino has 10-bit analog to digital converter, and this results in 8-bit value that can represent the number from 0 to 255, where 0 can represent the 0 duty cycle and 255 represent 100% duty cycle. And this can be done by this kind of code, where we can use analog read and analog write. And for analog read, we could use the parameter of the pin number of the Arduino, and for analog write, we could use the desired pin number and the value of the pulse width modulation output we need to send out. And now we'll talk about how we can use the pulse width modulation and duty cycle to control EC motors.